Hello, my name is Carrie Donnelly. I'm the director of the Chapel Hill Analytical and Nanofabrication Lab, or CHANNEL, at UNC. With me today is Casey Kuntz, a graduate student at UNC.
Today, I will be preparing some samples of gold nanoparticles so that we can measure their scattering spectrum. The samples are supposed to be 50, 100, and 200 nanometer nanoparticles, and 40 by 60 and 50 by 110 nanometer nanorods. Theory predicts that I should see a change in the peak position as the size changes, and I will use optical spectroscopy to help confirm this. I will be making these samples on small pieces of silicon wafer and will need some pipettes, deionized or ultra-pure water, solutions of gold nanoparticles and nanorods of different sizes, a polylysine solution, a beaker or other container to collect our chemical waste, and some tweezers. Notice that the silicon wafers look shiny and clean before we modify it. The first thing I will do is treat these silicon wafers with the polylysine solution. Gold nanoparticles don't necessarily like to stick to clean glass slides, but when they do, they often aggregate or clump together in bunches. Aggregated nanoparticles show different optical properties than isolated nanoparticles. By depositing a thin layer of polylysine onto the surface first, we can create a layer that the nanoparticles want to stick to, and it also helps to prevent aggregation. I will leave the polylysine solution on the silicon surface for about 5 minutes. This gives the polylysine a chance to settle out of the solution and adsorb onto the wafer. I'll rinse the polylysine off the surface of the wafer and dry the surface with air or nitrogen. I will deposit the nanoparticles in a similar fashion. A small amount of the solution is placed onto the wafer and allowed to settle for about 5 minutes. Once the solution has been on the silicon wafer for about 5 minutes, we'll rinse the solution off of the surface with water and dry the sample with nitrogen. To our eyes, the sample looks very much like it did before because the nanoparticles are too small for us to see with our eyes, and we would need a microscope to be able to see them. In addition to this sample, I've prepared other nanoparticle and nanorod samples. They are ready to be imaged with a microscope to make sure the particles have stuck to the surface, and I can also take some scattering spectra of them. Thank you for watching this video on preparing nanoparticle samples for optical spectroscopy.